Hi Year 3, this is the second video in our science topic on magnets. So last week you looked at pushes and pulls and how they are a kind of force, and we talked about pushing and pulling the blue tack and how we could change its shape with pushes and pulls. And then I had a toy bus last week. This time it's a car. If I put this along the table you would be able to see me pushing it forwards and pulling it backwards as an example of a force. So that was last week's learning. This week's learning is about how magnetic force is very special. And it's special because a magnet doesn't actually need to touch something to exert a force on it. So we're going to have some fun exploring what that means. Okay, for today's session, you're going to need your magnet that was in your learning pack. I didn't have a magnet like that because I'm filming from my house. So I've got some fridge magnets which are not quite as good as the magnet you've got. But I've got a snail, I've got a Star Wars ship which has got a magnet, I've got a little Russian doll, and this might look like plastic Lego, but actually this is a fridge magnet and it's quite strong. So you just need your magnet from your learning pack and just one small metallic object that the magnet sticks to. So I've got some suggestions of things that you might have at home here. You're also going to need a piece of plain paper and some felt tip pens for later on. So why don't you go off and go and get those things, and then I'll demonstrate what we're learning today. Okay, I'm going to demonstrate what we're learning today. So as I've said before, this Lego is actually a magnet that sticks to my fridge normally. And I've got a clear set of Perspex here. You can see me bouncing it up and down. It's a clear sheet of plastic, and on it there's a drawing pin and a paper clip that's got metal inside the plastic coating. So this is just me showing you that if I put the magnet, hopefully you can see that the magnet is some way under the Perspex surface. So I'm not touching these metal objects, but they are still moving around and they're sliding around as the magnet's pulling force acts upon them. But the magnet isn't touching the drawing pin. If you don't believe me, try this at home with some objects. See if you can maybe put your object on a piece of paper and get a friend or an adult to hold the magnet and try and move it around without touching. And you'll see it does work. Okay, so this is going to be the end result of today's learning. I've got my metal paper clip, I've got my magnet, and if you look, I've drawn a maze. So I've got a starting point. I'm imagining on my maze that a mouse is travelling along. I know it's just a paper clip. And I've drawn a track on a piece of paper with felt tip pen with some loops and dead ends in it, and also something dangerous for the magnet to try and avoid, and a reward at the end of the maze. So my mouse has got a piece of cheese. So let me demonstrate, hopefully, that this will work. So I'm going to put my paper clip on the starting point. I'm going to put my magnet under, and as if by magic, my mouse is starting to travel along the track. So underneath this piece of paper and this sheet of Perspex, I've got my magnet. And here comes, if I go this way, it's a dead end. The cat's going to eat me. Perhaps I better go back the other way and head for the cheese round here. So over to you guys. Do some experimenting with your magnets and have lots of fun making a maze. I look forward to seeing them on Zoom. Bye Year 3.